Hi students. So in my previous video I have talked about dictionary comprehension with examples. In this video I will be talking about generator, generator expression, generator function and advantages of generator over list. So before I start with generator, I want to make you remember about something that I discussed in video 4. And in that video I explained all these codes. I created our own iterator and solved this problem. So this was the problem. I wanted to print I to the power I for all I less than equal to user input. So this was the problem, and we solved this using creating our own iterator. And yeah, so are we done? Actually not, because see, now you can realize that for each time, like if we want to create our own iterator, each time we have to implement these two methods, iter and next. So, and we also have to check this condition, this raising exception. So all these things we have to do this manually. So this is the issue actually, and generator comprehension comes into play as a solution. So generator is nothing but a special type of iterator. So there are two ways to generate generator, and they are generator expression or generator comprehension and generator function. So let's start with generator expression. This is actually a single line of code. So if mygen is my generator object, so here this mygen is actually generator object. I will show you the output. So, and we use, as I said, parentheses to represent generator. And so the problem was I want to print I to the power I for I in range 6. So as you know, range is an iterable and 6 is not inclusive, so it starts from 0 up to 5. So yeah, so let's print mygen. Print mygen. Okay, so let's see the output. See, so this is my generator object, and as I said, generator is nothing but a special type of iterator. And as we know that to get a value from an iterator, we use underscore next. This is the function, or we can use next method. Actually, this internally works as underscore next. So we have discussed all about these things in my previous video. You can watch all of them. So if we print, we get 1. So why 1? Because it starts from 0, and 0 to the power 0 is evaluated as 1 actually. I can show you also. Wait. So if we do like this, 0 to the power 0, we get 1. Okay, so okay, so it starts from 0 and it stops at 5 each time it calculates this value, and this is my iterator. Iterator is used to get a value from a sequence one at a time. So first it returns 1 for 0 to the power 0, then increments. So if we call again, so 0 1 2 3 4 5. Okay, so let's see the output. See, this is for 0, then 1, then 2, 3 cube, 4 to the power 5, 5 to the power 5. Okay, we can also use for loop, because I have already said that for in we use iterable here, and every iterator is an iterable. So if we use mygen and just print le, so we'll get the same output. See, okay, we can also add condition here. So if we want to exclude this first one, so if I greater than 0, so yeah, we are done. See, it starts from 1 and it ends at 5. And that's all about generator comprehension or generator expression. Okay, so this is the alternative way, and you can just compare between this method and this method. Okay, so you can realize that how much efficient it is. So these two methods, iter and next, is actually, they are taken care by generator. So this becomes the behind scene fact in this case. Okay, so the another alternative way is using generator function. So what is generator function? So this is almost similar to our normal function that we use. We perform some operation, then we return the value, although returning portion is optional. Yeah, so this is similar to our normal function, but we use a new keyword, that is yield, in place of return. So the basic difference between yield and return is, return actually exits from the function and it doesn't remember the state of local variables. So next time when this function is called, it starts from the very beginning again. But when we use yield, it becomes a generator function and it returns a generator. So generator is nothing but an iterator. So iterator actually sends the value to the caller, and next time when it is called, it remembers the state of local variables and it starts from where it left off. So yeah, that is how it works internally. Okay, so let's start with our own generator function. I'll solve the same problem and another alternative way using generator function. So let's define our generator function, myGenFun. It takes max. This is the limit actually. Default value is 0. So then I want to print from 1 to 5. So num equal to 1. Then file num less than equal to max. And then I want to do something like this, num to the power num, and then num plus equal to num plus equal to 1, and that's right. So if we use return here, this becomes a normal function. Just num plus equal to 1 comes before return. So this is a normal function that we use. So how it works is, it starts from this statement and it exits. When it encounters return statement, it just exits from the function, and it also forgets all the values of the states of local variables. So num here is a local variable. So when we again call this function, it starts from the very beginning. So means the very next statement, very first statement, that is num equal to 1. But if we use yield here, yield num to the power num, this becomes a generator function. And actually at least one yield makes a normal function a generator function, at least one. Okay, so next, so as I said, this returns a generator function, generator object. Generator function is this, and it returns a generator object. So if my generator object is this, so if generator function, and if I pass 5 as my max value, then if I print this my gen object, my gen object, if I just print this, see, this is my generator object. This is actually for this for loop. Okay, so now we know that generator is nothing but an iterator, so we can print this values using for loop as we have done here. So we just take this and then same thing. So this becomes my generator object. Okay, see, same concept. This is for this print statement. Okay, so now you can realize that the idea is actually same. This is my generator expression, this is my generator function. Okay, so how it works internally is, this is my max value. Okay, so when I send 5, so max becomes 5, num starts from 1 and checks num less than equal to max, so it is true. Yield num to the power num. So what yield does is, yield actually sends the value, current value, that is 1 to the power 1, and it returns a generator. Generator is nothing but an iterator. So iterator sends the value one at a time from a sequence. So sequence is 1 to 5. So first it returns 1 to the power 1. So it prints. Internally it uses underscore underscore next, and it jumps to the next value, that is 2 square. So 2 to the power 2, and then it returns that value. Then it again uses underscore underscore next, and it goes on like that. And when it reaches 5, it becomes 6. Then this condition becomes false, and it comes out of the loop. Okay, so this is all about generator function. So we discussed about the two ways we can use generator, and what is generator, we discussed about all these things. So last is, so what is the advantage of generator over a list? So the main advantage is, when you use list, let's say we have a list of 5 elements in memory, we allocate memory for all the 5 elements. Okay, but in case of generator, so there is a concept of call by need. So only when the value is needed, then only the value is allocated in memory. And so the main thing is, at a time only one memory allocation is done in case of generator. But in case of list, if we have thousands of records, memory allocation is done for every records. So let's say we have a huge file, let's say thousands or millions of records. So if we use list in that case, so you can realize that, and let's say we have a file, and as I said, we have millions of records, and what we want to do is we want to do some operation on each row. Let's say we want to update each row. So at a time we are performing some operation on one row. So there is no need to save all the rows in memory at a time. We are just performing on each row. So in that case we use generator, because generator uses one item at a time, and it allocates memory for that item only. It doesn't allocate for the whole sequence. So this is the difference, and as you can realize that this is more memory efficient. Okay, so that's all about generator. Before I leave, I want to show you something about generator and iterator. That is, so from this generator function, as you can realize, so this is my limit actually. So if I don't give any max value, and so what I want to say is, so if I do like this, let's say this is my special generator function, okay, and num starts from 1 while true, and just yield num, and num plus equal to 1. That's all. So there is no limit. So this is an infinite while loop. So what we are doing here is, num starts from 1, this condition is never false, so it just keeps on increasing the length of the sequence, and it starts from 1, then it becomes 2, so it keeps on adding the elements at the end of the sequence. So if we just print my special generator, so obviously we'll get generator object. See, now the special part is, if we do like this for LE in my special generator, as you know, this is my generator, and this generator is nothing but an iterator. So just print LE. Can you guess what is the output? Actually this becomes an infinite loop, and we have to stop it manually using keyboard interrupt. So let's do this. See, so we have built our own infinite sequence using generator. Yeah, and the next thing and the last thing for today is a new concept. I have already talked about this function before. As I said, this function takes iterable as an argument, and it returns an iterator of that argument, from that iterable. There is another purpose of this function. This takes two arguments. The first argument is a callable object, that is a function, and next is a sentinel value, that is a guard value. So sentinel value equal to some value, okay. So yeah, this is the syntax. So if we do like this, so before that I want to show you something. Int, so if we call int, it returns 0. So if we use this and we just do like this, my infinite sequence equal to a generator element for element in iter, as I said. So wait, so what I did is, this is my iterable, this returns an iterator, right? So this is the callable, as I have shown you that if we call int, it returns 0. And how it works is, internally this returns 0, and iter checks if this 0 is equal to 1 or not. So this is the guard value. So each time it checks this return value with this sentinel value. So it keeps on checking until the condition is false, condition is true. So as we are not manipulating the value, so it always returns 0. So this condition never becomes true. So this becomes an infinite sequence. So if we print my infinite sequence, so obviously this is my generator, and if we do like this dot underscore next, as you can guess, sorry, wait, this is my infinite loop actually, so I have to comment out this, then see this 0. So if we just do the same for LE in my infinite sequence, and if we print element, now you can guess it will keep on printing 0 for infinite times, and we have to again manually stop it using keyboard interrupt. So yeah, these two things are some advanced things. So yeah, that's all about today. In the next video I will start with I will show you the, as I said, memory efficiency and time efficiency using the two modules, get size of and time it. Bye bye.